Hi folks, and thanks for joining me. I appreciate you watching the last video here on the Zenith with that defective output transformer we were able to make a repair on. Let's turn our attention now to the power supply circuit, and you're looking at the schematic. For that, you can see here's our 6 volt input location, and what I'm going to do is just spend some time and we're going to just review everything, trace everything out, and see if everything matches the schematic. That'll be the purpose of this video, and then we'll follow up in a secondary video and start getting the new capacitors in and any resistors that are out of tolerance as well. You'll see the B plus section of the power supply takes off from here and just routes across here as such, and then you've got these other points here that go up to the tubes. So anyway, let's get started here. We'll kick things off here. This is our 6 volt input, and the indicator of course is our red thicker gauge wire that was used here that I clipped off here in an earlier video. But it attaches to one side of the switch, and then you'll see this capacitor here that's attached to that same connection that goes back to the chassis ground. If you reference the schematic, you'll see that this is called out as a 0.25 microfarad cap, and that's what we have here, rated at 350 volts as signified here. So this component matches, and everything is correct to this point. Now let's look at the second contact of the switch itself, and we'll follow those components out and see where they tie back into. So if you're following the schematic there in the picture-in-picture, again I flipped the switch here. We're looking at the other side of the contact here, and you can see that called out on the schematic. And you'll see that we've got this lead wire here that comes across and goes back to this tube socket. Then once it leaves this tube socket, there's another jumper or a lead that runs back over here to where the speaker itself plugs in, and you'll see that called out on the schematic as well. And that matches the one of the field coil connection points, and it's actually the lighter colored wire here. The other side, which is black, that attaches to the field coil, you can see is on the negative side, or grounded at this point here. And just to confirm that, you could hook up a meter, which I've already done, and just make 100% certain that this is grounded back to the chassis, and this other side again goes to the switch itself here. Now you may look at this on the schematic and you'll see it's jumping over here to this tube. What tube is that? We're looking at this thing upside down. Lots of times I'll just do a quick hand drawing of the underneath side of the chassis itself if I don't have an underneath side view available, or I'll show you just another trick you can use here. Just simply take your printed copy of the schematic and turn it over and place it against a light. So you can see here I'm looking at the inverse view of the schematic, and you'll see the 6T7 tube called out beside the vibrator itself and the little choke or transformer. Going back to this lead here that attaches to the 6T7 here, pin number 7, so you can see that would be our DC input to the heater itself, and pin number 2 would be located here. So we're counting here clockwise from underneath, pins 1, 2, 3, 4, 5, Number 6 is not used on this particular tube. There's no socket there or no pin for that. And number 7 here. And you can see pin number 1 is not used on the tube as well, but it's just used as a terminal strip or solder to locations for components. So 1 and 2 are tied together. Just don't let that confuse you. If you're out there working, you'll see that in many cases. But pin 2 here is tied to chassis ground. And 7 again will be our heater string voltage, in this case our 6-volt supply. Moving along here, if you look back at the schematic, you'll see the type 38 tube. Focusing again on the heater string itself, and you can pick it up here. And I know some of this may not show up well on video, but this routes back again from our 6-volt string here for the heater, comes back over here with the plus side to pin number 5. And the 38 tube is a 5-pin tube, pin 1 being here, and this attaches back to ground itself, which flows back over to the ground connection itself here on the speaker and field coil plug. Pin number 2, we'll get back into that in just a bit, but it's identified here and also goes back to the same plug, and this attaches over here to the output transformer, but more to come on that. So we're good here on the schematic up to the type 38. Let's move along. You can see that I flipped the radio over so we could take a look at it. Here's the dial light that's called out on the schematic, and the 2 leads, and you can see I'm missing the lamp itself here. And I don't think I have any of these. It's a 2.9 volt, 0.17 amps. We'll have to look at that. May have to order one, but you'll see the 2 leads here working their way back down through the top side of the chassis to underneath. So let's flip this back over and look at the underneath side here. Our first exception here. Here are the 2 leads that come from the pilot lamp itself, and you'll see this goes back to ground here. The black lead, the lighter coated lead here, solders directly back to the other side of the switch as depicted on the picture-in-picture. What's missing is R11, unless R11 is built into the socket itself. I'll flip this back over in just a moment. We'll look at it closer. But my bet is someone removed R11 and wired this directly to the 6-volt input supply, and more than likely they're just using a 6-volt lamp in the socket. Again, just moving kind of left to right here on the schematic, you'll see the 6 delta 8 tube, and looking at this from underneath, this is the tube. Pin number 2 will be the plus side of the DC, while pin number 7, the other heater, goes to ground, and those cables are routed back in this direction, and you'll see they tie back into this tube, which again is called out on the schematic as 6S7G, and everything matches here as well. Let me just confirm the pin numbers here for the 6S7. We've got 2 and 7 here on the 6 delta 8. Let me just confirm 6S7. And back on the 6S7 here, pin number 2 is used as the negative side, and pin number 7 is tied into the plus side. of the heater string. So coming off of this connection point, you'll see up next we've got number 9. The components there shows a coil, and as well as C9. Let's follow the part number 9. If you look at the description, it shows an RF choke. So let's just look at the tie-in point here for the choke, number 9, which should tie back into C9. It ties back into pin number 2. Let's just make sure that we're good there. I had mentioned this lead here coming off, coming over to the power supply section. You can see it attaches here to a simple terminal strip, and what I first called a capacitor, or what I thought was a capacitor when I was doing the introduction video, this appears to be the RF choke. And you can see we connect here, and this goes back down to the synchronous vibrator, pin number 3. And if this was plugged in, the vibrator itself, and we'll spend more time on the power supply. I'll share my limited knowledge there on a future video. Pin number 1, pin number 2, pin number 3, looking from underneath, and that coincides with this location here. So everything appears to be wired correctly. We'll spend some more time, see if we can better understand the characteristics of the RF choke as well, so that can be reproduced if necessary. Now there's another connection point here soldered on. Let's continue to follow that along to see how it ties back into the circuit here. I've reached a point now where I can't physically tell where the component leads are leading me to, so it's time to take this section out, or attempt to do so. And I may have to start actually cutting some of the components out as well, just to make room. And if I do so, we'll document things if I'm skipping around here on the schematic. But let me go ahead and try to remove this dividing section here for the power supply section. As I was pulling this up here, a couple other things I'm going to have to do. I've already cut the lead here coming over to the 6-volt side that goes to that little small terminal strip here that I mentioned that has the RF choke, or one of the 2 RF chokes. I'll feed it back through here. In addition, we already had this one line cut off. We had no idea where it went. We'll have to pull it through, and then this other line here should be our B plus coming from the power supply itself back over here to the where the field coil itself and the output transformer are attached through the speaker plug. So I'll snip that back in this area as well, so we can feed it through, and then hopefully just reuse this, or I'll replace it as needed. Okay, I think I have it loose here. There's a look at the plate itself. Now we can get back in here and take a look at this better. And I'm curious to know what this lead here went to, the one that was what we found cut. So we'll definitely investigate that as well. Let's get back to the schematic now and find out where this lead goes that tied back to pin number 3 on the synchronous vibrator here. Reflecting back on the schematic there in the picture-in-picture, we were looking for C9, Charlie 9, and it's actually located right here. We already said this was pin number 3. This is where one side of the RF choke resides. And then you may be able to see we've got this capacitor here, the big guy, 0.5 microfarad, I believe it is. The 22-199F attached here. So that indeed matches the schematic itself. So we can close that loop off between the choke, part number 9, back over to C9, and you'll see we still have a couple other connection points there. It should go back to the center tap of the transformer used here in the synchronous vibrator circuit as well, which is most likely this location here would be my assumption at this point, or it should be right here. It's time to skip around here just a bit on the schematic. These two capacitors right here, I'm going to go ahead and cut these at the ground location just so I can lift those up and just confirm my pin numbers that they go to here on the synchronous vibrator. But these should be 0.01 microfarad caps. These are the buffer caps, and we'll talk more about those in a bit and what they actually do. And they're real high voltage caps, but we'll need to definitely replace these aging capacitors for sure. They're called out here, if you go back to the schematic, as C10, or should be. And again, that's what I just want to confirm. I've got my pin nomenclature correct here on my hand drawing. Let me just go ahead and clip these here so I can kind of wiggle them around and get back underneath here and look at this tube socket here just a little bit closer. I'll try to hold this where you guys can see it, but indeed I do have them called out correctly here. This was the ground side here that I cut that goes back to this connection, and we already said this was pin number 3, so moving back counterclockwise, pin number 2, and you can see that's where one of the C10s attached to. Pin number 2, and then we already said pin number 3 is where the one of the chokes attach, and pin number 4 where the other 0.01 high voltage buffer cap resides. So we'll replace those, but they're kind of out of the way, so that matches the schematic. And then I can do a little other probing here, and we can see the transformer probably tie-in points here for the secondary side as well. Back on the schematic a minute before we move back to the primary side of the transformer. Let's go back here to pin number 4, pin number 2, where these buffer caps attach. Right here I've got a black lead that attaches here to pin number 2 that goes back into the transformer here for the vibrator. And you can see that's actually going to be the bottom side, or should be the bottom side, according to the schematic on the transformer itself on the secondary side. And if we go back over to pin number 4, that's this connection point here, this lead wire that goes back to the transformer, and that should be the top side is notated on the schematic itself that you're looking at. We'll do some DC resistance checks here and just make certain that this transformer is good in the following video. Now let's move back to the primary side of the transformer. Okay, back to pin number 5 as a reference here on the schematic, and it's physically located here. And you can see I've got this lead wire here attached that comes back down, goes to the transformer here. Reviewing the schematic again, pin number 5, you'll see how it routes back through and is shown as again as the primary side of the transformer. Now let's look at the other side. It should tie back to pin number 1. Let's see if we can identify it real quick. And it should be right here. As we already said, that's pin number 2, pin number 1. So this lead right here, when we do the DC resistance checks a little bit later, should be the other side of the primary feeding the vibrator there, pin number 1. My bet is the resistors I'm looking for are down here underneath this shrink. It's this location. Let me go back here and get C9 removed, or just pop it up here out of the way. I'm just cut the negative lead. It goes back to ground. And our resistors are 10, 2 of them. One of them probably resides here, and the other resides right here. Let me go ahead and cut some more of this out, and we'll cut this back and just make sure our 2 resistors here we're trying to identify are located here, and they're tied to the correct tube sockets based on my documentation. Okay, you can see I've been hacking away here at this, and definitely we've got a resistor hidden right here. And that goes back from pins number, pin number 1. We'll go back to the schematic, and indeed that's what we're showing there, pin number 1. And the 2 resistors here tie together. At this point there's another resistor here, and that would tie back into pins number, we say 1, 2, 3, 4. Number 5 is called out on the schematic itself. So that indeed matches. Another resistor here I've got to replace. Alright, so what else are we missing here? Look at the schematic. We've got R10 now notated. And by the way, the other side where I said the 2 resistors tie in together here, pin number 6, which attaches itself there to ground, is notated, so that closes out that loop that we're missing. C15, number 8, and we still got to find number 6, C11, C12 back over in this section. So let's see if we can unearth those, and that will wrap things up here on seeing how things are tied in and what lies ahead here for doing some testing, hopefully just testing, and replacing these old caps and getting the power supply itself back together. As I did earlier, I'm going to just go ahead and cut the lead here for this electrolytic capacitor. This is one I think it was put in after the fact, and you can see it's a 10 and 10. It's a dual capacitor rated at 450 volts. And I'm going to just go ahead and cut it here at the positive leads so I can get back up here and take a look at the components here around the power choke itself, and what I thought was a circular like terminal solder location. It appears to be the second RF choke that I was looking for. So let me just go ahead and snip these. And the schematic itself called out for C11 and C12 if you're following along there in the picture-in-picture. C11 being a 2 microfarad, and C12 there, if my eyes are correct, about 8 microfarad. And again, I don't think there's any harm there. We'll look at the spec if we can find anything there on the vibrator to make sure that the capacitor value here is not too high. Let me reposition things here and kind of pull this around where we can get to this other capacitor, and then take a look at the RF choke here, if indeed that's what it is. I tried to position the RF choke here where you guys could see it, and pulled it out, but I want to be extremely cautious not to damage any of the windings here. we'll do some testing on it here. But here's that mysterious lead that I was looking for that went nowhere, that had been cut, and I think my suspicion was right. It actually routes back down through the electrolytic can that resides on the top of the receiver. So someone had replaced that section of the electrolytic, it appears, with the Sprague Adams capacitor at some point in time over the years. Let me just double check everything here and see if we can tie this RF choke here into the components and just determine if it's wired correctly. I'll try to hold this up just for a moment so you guys can see it, but the part number there is 22170. I think it's a 0.1 microfarad cap. Don't hold me to the value, but it does tie back in here to the RF choke, and that's indicated there on the schematic that you're seeing there on the picture-in-picture. So I think we've identified everything, and it appears that the power choke here, with all the tar on it and a little spider left over from the day, does tie in as well, is indicated here, part number 6, into C11 and C12. We'll have to do some testing here to make sure that these RF chokes, this one, which looks like it's just a handmade choke, and this choke here is good, as well as the power choke is good. I'll probably just go ahead and cut all this stuff loose and completely clean up all of my connection points here, and just resolder everything in new as I get into the electrical restoration itself. So it looks like my only exception, just looking at the physical layout, best I can tell, if you go back to the picture-in-picture and look at that, and you can see I've got my hand drawing up here. I haven't color coded the rest of this in, but R11 was missing. Everything else seems to be complete where our power supply circuit here resides. That will be my first focus. I'll go ahead and rebuild this section of the radio, get the plate back in, and try to be done with it, so we can test the synchronous vibrator and see if it works. Then we'll move over here to the remaining section and take care of the detector oscillator IF section, the power output tube, etc. Thanks again for watching, folks.